Hello there, welcome to this course. In this course, I teach you all the core concept of C++ programming language. The content of this course will be installing tools for compiling C++ codes, writing your first C++ program, learning how to compile and execute C++ programs, variables, naming conventions, inputs and outputs, data types, casting or type conversions, blocks and scopes, strings, string methods, escape sequences, operators, order of operations or operator precedence, conditionals or if-else statements, switch statements, and then a project for practicing conditionals. We will create basic calculator. Then we will learn about loops, while loop, for loop, break and continue, arrays and array methods, structures, references, pointers, functions, and then another project for practicing functions. We will build a program for converting currencies. After that, object-oriented programming, classes and objects, just basics for beginners. And finally, we will bring all of them under one project. We will build a product manager application. Let us jump to the browser and install C++ compiler. Download TDM GCC. Download TDM GCC. Here you have this one for 64-bit and 32-bit. Click on this one. Download is finished. Go to your download folder. Downloads. Then here you have the installer. Double click on the installer. Create, manage, remove. We create. Choose the second option. You can also select the installation directory, but for me this is okay. Next, and now here you can choose versions or components. So here you also have the option add to path. Make sure to check that. When you add this to the path, you can use the compiler from anywhere using your terminal. It says read the TDM GCC readme file, recommend it, finish. In the future, if you see something is wrong, something not working, you can refer to this readme file. Open the terminal to check if it is successfully installed or not. Type here G++. So the installation was successful. Create a folder somewhere on your machine and open it in Visual Studio Code. Open with code, and here we create a file, hello world.cpp. .cpp is the extension for C++ file. Enter to create the file, and it also recommends to install extension for this language. I install it. Let us write our first C++ program. First, in every C++ file, we kinda have to import the IO stream. Number sign include IO stream, and then using namespace std. I will explain everything, don't worry. Integer main cout hello world return 0. This is a very simple C++ program. All what it does is printing hello world in the console. To see the result or the output of your program, you have to compile your program and then execute your program. So how to compile C++ program? Open the terminal here. You have here the tab terminal, new terminal. In the terminal, type and then the name of your program, hello world.cpp, and hit enter. Now here you have a new file, a.exe, an executable file, binary file. You can execute this file by clicking twice or double click on the file, or from your terminal you can just say a.exe and enter. Here you see the result, hello world. You can also give the executable file a custom name, for example like this, g++ hello world hyphen o, and then your custom name, hello world. Now .exe for binary file and hit enter. Now you see here hello world.exe, which is much better than a.exe. Now if you type here hello world.exe, you get the result. Or you can go to the directory here. When you double click on it, it also shows, but the terminal closes immediately. That was very simple. Now let me explain you this code. This is basically the syntax of C++ code, or the syntax of C++ program. On line 1 you have number sign, include, angle bracket, IO stream, and then close with angle bracket. It is called the header file library that lets you work with input and output objects such as cout for printing something in the console. And then on line 2 we have using namespace std. It means that we can use names for objects and variables from the standard library. Don't worry if you don't understand them right now. Just know that line 1 and line 2 will appear always in your program. So on line 3 we have nothing, so the compiler ignores white space or empty lines. Sometimes you should give one line white space for more readability. On line 4, the int main bracket. This is also something that will always appear in your program. So the main method is mandatory. The int is a data type. It stands for integer because this method returns a number, in this case 0. So int main is a function that returns integer. We will talk about functions later in this course. Then on line 6 we have COUT, which is pronounced as cout. It is an object used together with the insertion operator to output or print text. In our example, hello world. It prints hello world in the console. And then you have semicolon. Semicolon is part of the C++ programming language syntax. So it is mandatory. If you remove semicolon, you get error. So it must be there. And on line 7, the return 0 index this function, index this program, and returns the number 0. In case if you don't want to include the standard library this way, like using namespace std, you can remove it and then add here, because the cout is part of the standard library, std colon and it will work. So every time you want to print something, or if you want to get something from the user, or anything else that has to do with the standard library, you must use it this way and you have to include that in that line. So that is why you have to include it once, so that you don't have to add this in every line. So Control Z, it is much better. In conclusion, brackets, semicolon, and curly braces are part of C++ syntax. Without these special characters, your program will crash and will not work. In case you don't want that the compiler executes some part of your program, you can comment out those lines of codes or that part of your program. Or in case you want to add extra documentation, extra notes in your program, you can also use comment. So in C++ you have a single line comment and multi-line comment. For single line comment you can use double slash and then here say this is my first C++ program. And then to add multi-line comment you can use slash star and then close with star and slash, for example like this. Now the compiler will ignore the whole thing inside this comment. Programming is about processing data, about working with digital data. In the real world, we have many data types. We have username, we have user age, we have user's salary, and etc. We have pictures, photos, sound, videos, text data, number data. Then we have different data types in numbers. We have integer, we have decimal, we have numbers with fraction parts. So there must be a way to create and store those data. Variables are used to store data temporarily during the lifetime of your program. For example, we create here int, which is short for integer. Let's say age, and then we assign a value, let's say 30. Now he is 30 years old. We stored the age in this variable, we called it age and the type is int. We can store the name in string name, for example Akianus. When you work with a string, you have to include a string. So the same way here, include a string, and then we add here also that one, the name, and we say his name is name, and his name is Akionus. So this is how you create variables. We will see many examples of variables later in this course. Naming conventions or identifiers in C++. Identifiers or the name of your variables must be unique. It is best practice that you give descriptive and complete name, full name. It helps yourself in the future. It helps your co-workers, your colleagues to work with your program and understand your program much better. Instead of describing your code line by line using comments, it is much better to give descriptive and complete identifier or name. About the syntax of a variable, the first one is the data type. The second part is the identifier or the name. Then you have equal sign, which is also called assignment operator, and then the value. So the identifier can contain letters, numbers, and underscores. The identifier must begin with letter or underscore. It cannot start with number. You will get error. For example, in the age, if I say 1, then you get immediately error. So cannot start with number. Identifiers are case sensitive. So if I create here a variable with the identifier my age, and in the age a is uppercase, and another variable with my age all lowercase, so they are different variables for your program. They are different, so identifiers are case sensitive. Identifiers cannot contain white spaces or special characters like number sign, percentage, or etc. If I add here white space for the age, again I will get error. Or if I add here special characters like equal sign or this character, so only alphabetic characters, numbers, and underscores, also not number at the beginning of your identifier. The identifier also cannot be C++ reserved words. Like if I say here integer and also call this int, it is also not allowed. Again, error. So the words you see here like int, main, string, cout, return, these are called C++ reserved keywords. You cannot use them in your program as identifiers or as something else. You can only use them as part of the syntax of the programming language. You can create multiple variables at the same line. It is not necessary that you give that type every time. When they all have the same type, you can just use comma, for example, age, and then you can say year 2023, and then another comma, month 9. That is just an example. You can create multiple variables of same type using just a comma. And the same way, if you have multiple strings or texts, You can use comma, name, city, for example, Kent, and then comma, country, some funny country, France, for example. So this way you can create multiple variables of the same type using comma. If you don't want that you accidentally change the value of a variable, you can create constant variable. Const, and then the data type, integer, id, and then a value. Let us say 100. For the constants, it is also best practice to use all uppercase for the identifier. Like id, it is much better. So if you try to reassign this constant variable, you will get error. So you cannot change its value. Let us talk about inputs and outputs in C++. These two operators are used a lot in C++. So you have first this one. This is called insertion operator. And then you have the other one is called extraction operator. So the insertion is used to print out to the console, and extraction operator is used to get from the console or from the user. Let us say here something int h, and then we ask the user to enter the age. Please enter your age. This is just a message, and then we use cn and extraction operator age, and then here we print again and say you are age years old and exclamation mark. To make it more readable, let us also add a new line here. This backslash and n is part of escape sequences. We'll talk about that later. Let us compile and execute our program. G++ input and then a. Then here you see please enter age. I say here 30 and enter, and then it tells me you are 30 years old. So this is how you get the user input from the console. Data types in C++. You have these basic data types in C++. These are built-in data types. You also have a string for working with texts, but a string is not a built-in data type in C++. That is why you have to include it using the include keyword. So first you have boolean for storing true or false values, and it takes 1 byte space in the memory. Then you have char for storing single character. It can be single alphabetic character, single like letter or number or ASCII values. Then you have integer. It takes 2 or 4 bytes. It stores whole numbers without decimals. Then you have float. It takes 4 bytes in the memory. It stores fractional numbers that can contain 1 or more decimals. Float is sufficient for 6 to 7 decimal digits. Then you have double. It takes 8 bytes in the memory. Again, it stores fractional numbers and then containing one or more decimals, and it is sufficient for storing up to 15 decimal digits. So double takes more space in the memory and it can store larger numbers, and it is more accurate than float. Finally, strings takes space depending on the length of the string. If you have long string, it will take more space. If you have short string or short text, it will take less space in the memory. Let me give you some examples of these types. For boolean, you type here bool, say is okay, and then you give here true or false. Let us print it to the console. Is okay. Basic types, and it says 1. So for the compiler or for the machine, true is 1, false is 0. If I change this to false, then compile again, execute again, now you get 0. Now let us initialize a char variable. So you use the keyword char and then let us call it single character. To create single character variable, you use a single quote, not double quote. For example, you say C. Print the single character variable in the console. So C. Interesting side notes about variables. There are some terms for variables. You have declaring a variable, you have initializing a variable, you have assigning a variable, and reassigning a variable. Declaring is when you just create a variable with a type and identifier. Initialization or initializing a variable is when you create a variable and you assign a value, you give a value. Then you have assigning a value is when you declare a variable without any value and then you give a value. For example, here you say bool is okay. This is declaring, and then assigning a value is okay. Use assignment operator and then give a value. For example, true. And then when you give a new value to a variable, that is called reassigning. So we change the single character from C to, let us say, Y. Now you see here error because I used double quote. Let us compile and execute. Now you see Y. You saw example of integer in the previous chapter, so let me give you another one again. Sum, let us say this number plus this number plus this number divided by this number multiplying by this number and minus this number. Let us print to the console and see the result. This is the result of this mathematical calculation. In integer, you have two more data types. You have short integer and you have long integer. that we will talk about in the next chapter. Then we have float. We use the keyword float. For example, salary. Let us say 3,360.59. An example of double salary of all people. This number point in this one. In the data types, you have also something called range, and out of range you have also overflow. Overflow happens when the number or the value is much higher than the range of a type. For example, if an integer can store up to 2 billion and you stored there like 3 billion, then overflow happens and you get a strange result. You will not see 3 billion, but you will see another number, not correct number, because 3 billion cannot be stored in integer. So when you see this words boolean, integer, float, double, they also have a specific size, a specific range that it can store only number or data in that range. If you give a value larger than the range, then you will get a wrong result and it cannot store that number or that data because it is out of the range or out of the size of that type. Control C, Control V, and here you see E. So E plus 15 means 10 to the power of 15. A string, let us say address, and then you use double quote for storing more characters, more texts. For example, Kabul, Afghanistan. And here also a custom message. The address is voila, the address is Kabul, Afghanistan. In conclusion, you have this built-in types in C++ to store data of these types and process these data in your program and work with these kind of or types of data. Let us talk about type conversions. We have two types of type conversions. We have implicit type conversion and explicit type conversion. What is the difference? The difference is that implicit type conversion happens automatically by the compiler, by the machine. Explicit conversion happens by the programmer that you manually convert from one type to another type. Of course, the types that you want to convert must be compatible. So compatible types can be converted from one to another. Let me give you an example. We talked about different data types in the previous chapter. We also talked about integer, and we also have short integer and long integer. Let me give you an example of short integer. You use the keyword short, and then your identifier, age 30. Short can store up to 32,000. integer can store up to 2 billion, and then you have long integer, it can store much larger number. Total hair of all people, and then here gave a very large number like this. Here I create another variable short to int. Now because the range of short is much lower than the range of integer, there is no problem. But if I store the value of total hair of all people in integer, we will see overflow and unexpected result. So implicit casting or implicit type conversion happens if there is no chance of data loss. So let me show you. About the type, there is also another library. You have the type info that you can import, and then use type ID and then pass here your variable, use dot operator and then name. It will print the name of the type. For example, let us change it to the total here. So here it says warning, overflow in conversion from long int to long int. Changes value from this to this. Long and long integer are the same. But if I change this to long, we will not get any error. So here you see 30 and x. 30 is the short age and x is for extra long. If you change this to age, this will be S for short. 30s. So if you have a number larger than the range of integer, you can store it in long, and if you have a number larger than the range of long, you can store it in long. Casting from a type with lower range to a type with a larger range will not throw error, and it will happen automatically. If you try to convert from a larger range to lower range, then you will get error. If I give this now to this integer, I will get error, but if I specify here explicitly myself, I will not get error, but I will get unexpected result. So I want to convert this to integer. We got this result, which is not what we expected. So that is the difference between implicit casting and explicit casting. If you want to convert a type to another type yourself, you use parentheses and then the name of the type. If the types are compatible and there is no chance of data loss, the compiler will cast automatically. So this is how compiler does it. Short to integer and then integer to long and then long to long. It can also convert from short to integer and from integer to float and then from float to double. So implicit casting can happen this way by the compiler. But if you want to convert from one of these type to another type, you can use parentheses and the name of the type. It will convert the type, but the chances that you will lose some data. How to work with texts in C++. In this chapter, we are going to talk about strings and string methods. Let us create here a string variable, string first name, string last name, string full name. You can join two strings together using plus operator, or you also have a method called append. For example, first name plus last name, and then we print the full name to the console. So you see here Khalil Kozmi. You can do the same thing using append, the first string, and then use append, and then here pass the second string as argument, last name. You see both are the same. It was much better if there was a white space between the first name and last name. So we can here append white space, and then chain methods append last name, and that will be much better. You can do the same thing just using plus operator, and then concatenating with white space, adding another plus operator, concatenating with the last name. Now you see both are the same. What if you use plus operator or plus sign with a number and string? Let us see. Say int age, say 30, and then here first name plus age. You see here an error because in C++ you cannot add string with number. In case you want to get the length of your string, you have the linked method dot length (13). It says that this string is 13 characters long. For getting the length of your string, you also have the size method. Size method is just an alias for length, so it is just the same. Again 13. A string in C++ has index, and you can use the index number to get a character from your string or to change a character in your string. Let me show you. And then square bracket, the index number. For example, if you want to change or get the first character, you give the index 0, it starts from 0. And then if you want to change the last one, so if you want to get programmatically the last one, you use again full name dot size -1, because it starts from 0 and the length will be larger than that. That's why you have to give -1. Let's say the last one is now here I change it to capital L. You see here an error. That is because I used double quote, so it has to be single quote, because we are getting or setting just one character, so we have to give here single quote. Let me change this to the full name. Now you see instead of Kazimi it says Kazim L. If I change this to 0, we set now the first character. Now the first character is here K, and I changed it to L. If I get here now only the first character, it shows here L. So now it is much better and readable. So you can use index number to get or set the characters inside your string or text. In some situation you have to work with special characters, like adding a double quote in your text, adding single quote, new line, tab, and adding another special characters. So for this situation you need to escape those characters, otherwise you get error, you get compilation error. For example, if I want to wrap the word nice in double quote, I will get error. How can I escape this? Just using backslash and backslash. Now there is no error, and I will see the double quotes if I print this. It is very nice if you like the video. And the same thing with single quote. For example, if you want to store a file path, string contract PDF, and you want to store it in a variable, the path, you say C you see here error, and you can escape the backslash using backslash. Adding another backslash makes it escape, and here also you have to escape it. Now this is the result. So now you know if you add any special character and you get error, you can use backslash to escape that special character and avoid error. We have already talked about user inputs, but there is something about user inputs that you should know. Let me give you an example. By using the user input, we try to set the full name to something else. Cn full name. You will see like kinda shocking result. So now I have to enter a full name like, and then white space, enter. You see here just the first name and not the white space and not the last name. This is because when you use only the cn, you get just the first word. If you use white space or if you use tab, it means the termination of the input. So if you want to get a full text or the whole user input as a string, for example, the user enters a whole lot of explanation, then you can use getLine instead of cn. Let me show you. In getLine, you pass here the cn as first argument and your variable as second. I also add here a custom message that's much better. Your full name is. Also here a new line. This is also one of the escape sequences. You also have tab. If I add here \t, it means new line, and then also tab. Your full name is this thing. Now I have to enter my full name. White space, enter, and now in the new line and also a tab, your full name is Khalil Kazemi. So this is very interesting that you can get the whole line. Even if you enter here multi-line text, you get that by using getLine. Operators in C++. You have arithmetic operators, you have assignment operators, you have comparison operators, and you have logical operators. First, we are going to talk about arithmetic operators. Arithmetic operators are used to perform common mathematical operations. So we have all these arithmetic operators. You have addition, subtraction, multiplication, division, modulus, increment, and decrement. I am sure you know all of these, but I give you an example of them. Integer, result, 12 plus 11 minus 5 times 10 divided by 3. See out, and then here we say the result is result. So the result is 7. Let us do 35 modulus 7. The modulus gives us the remainder of division. So it is 0 because 35 divided by 7 is 5. The result is 5, so the remainder is 0. If I change it to something like 3, we will have a remainder, and you get the remainder. The remainder is 2. Then you have increment and decrement. Now we know the result is 2. We also can increment that by using increment operator. Result plus plus, we expect it to be 3. So it is 3. We also have compound operator for all arithmetic operators. For example, this plus something like 5. So it is the same as this one. Result plus 5. And plus plus is just result, assignment operator, result plus 1. But because it is 1, you're just doing plus plus. If you are adding other than 1, then you can use compound operator. Some other people also call it augmented operator. 2 plus 5, we expect it 7. So the result is 7. You can also use minus. You can do any arithmetic operator. So minus 3 because the result was 2, and 2 minus 5 is minus 3. And then you have decrement Actually, this was an example of decrement. Minus minus, it is like the result minus 1. It is minus 1. It is 2, we expect it 1. So the result is 1. And the same way you can do minus augmented 9, so minus 7. But you don't have times, you get error. Now assignment operator, we have seen assignment operator previously, so this one is assignment operator, and you can combine arithmetic operators with assignment operator, and that's also called assignment operator. For example, compound operators or augmented operators that you just have seen are also assignment operators. So if I do divided by 5, and this one, let us change this to, and then the result will be 108 divided by 5, and this is the same as the result we assign the new value, the result divided by 5. So the result is 21. So this is also assignment operator, that we assign the result of operation in the variable at the same time. And you have the augmented operator also for other arithmetic operators for timers. Let's see the result. Now this number, you also have the modulus, so 3. Then we have comparison operators. You have these operators in comparison operators. You have equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to. Comparison operators are used to compare two or more variables or values and check for equality and not equality and other these operators that you have. Here create two more variables, short x2, and then we create the same type y3. So x and y are both short, and then we compare here if x is equal to y or not. The result of comparison operators are always Boolean, so it is true or false. It says 0, which means false. And then we have greater than. Is x greater than y? Let us see. It is 0 because 2 is not greater than 3. Is x less than y? Is 2 less than 3? The result is 1, which means true. Greater than or equal to? Again, false. Is it less than or equal to? It is true because it is less than y. Comparison operators make more sense when we work with conditionals. You will see many examples of comparison operators later in this course. Logical operators. In logical operators, we have three operators. We have logical AND, logical OR, and logical NOT operator. Why logical operators? Here we have just one expression, so this is called an expression. What if you want to combine multiple expressions together? For example, here you say x less than or equal to y, and then you want to also check, is it greater than y? And then you combine again, is it greater than or equal to y? This is where logical operators come in. So we use logical operators to combine other expressions. And here we can use, for example, AND logical operator, the error gone. If we add also here another AND logical operator, and we have no error anymore. Let me explain you this expression. If x is less than or equal to y, and is x greater than y, is it greater than or equal to y? This expression returns true if all these three expressions are true. It returns true, otherwise it returns false. So AND logical operator searches for false. If there is one false, it stops and it returns the result which is false. Otherwise, if there is one true and there is another expression, it will keep just checking all the expressions until it finds false. If there is no false, it returns true. So here x is less than or equal to y, it is true. It checks the next one, is x greater than y? It is false, so it stops here and returns false. So let us see the result. So the result is 0, which means false. If we use here OR logical operator instead of AND, then the result is different. Logical OR searches for true. If there is one true, it stops there and it returns. So this one is true, it stops here and returns true. So the result is 1. Then you have NOT logical operator. NOT logical operator is used just to negate the result of another logical operator. For example, our result here was true. We can use NOT logical operator to just reverse the result. Then it will turn, if it is true, to false. If it is false, it turns it to true. So it was true, now it is false. You can combine multiple NOT logical operator, and each time you use it, it reverses the result of the previous one. So this one is false now. If I add another one, it turns it to true, and then false, and then true, and then false, and then true, and then false, and then true. So that is just an example, just that you know, otherwise it is just useless to do this. Or you can also wrap them in parentheses and then use a NOT logical operator to reverse the result. There are some advanced terms and concepts in logical operators that I really want to tell you, but I don't want to make this course complicated for beginners. If comparison operators, assignment operators, or logical operators are not clear, don't worry. We will see many examples of these operators later in this course. This is just the beginning of this course, so don't worry. Order of operations. It is very important that you know the order of operations because it does not work the way you think. Let me give you an example. Is this 3 times 2 plus 5 or 3 times 2 plus 5? What do you think is the result? 6 plus 5 or 3 times 10? The result depends on the order of operation by the compiler. Let us see the result. My answer is 11. Let me know your answer in the comment. Not the answer that we will see in the console. The result that you have now in your mind. So 11. Why? Because this happens first. 3 times 2, 6, and then plus 5. Because the compiler does the multiplication and the division first, and then the rest. Precedence level by the compiler. First, parenthesis. If you want to change the order of operation, use parenthesis. Then you have multiplication and division. Then you have subtraction and addition, or the rest of them. So we can change the order of operation here just by using parentheses. So now it is 3 times 2 plus 5. How did I come up with this 10? It is my mistake. This is actually 7. It is not 10. I just it is very late at evening and I'm also hungry. So that's why. Yes. Probably you will answer something else in the comment. So 3 times 7 is 21. So in conclusion, parentheses have the highest priority or the highest precedence, then multiplication and division, and then the rest of them, addition, subtraction. In this part, we are going to talk about conditionals, if-else statement, and switch statement. Conditionals are used to add decision making in our programs. Conditionals are used to execute certain codes based on certain condition. To do stuff based on some conditions, you can use if-else statement or switch statement. Here is the syntax of if-else statement. You have the if keyword, parenthesis, and then condition 1, and then you have curly braces. Here goes your codes, and then you have else if, then you can add another condition. Let's say condition 2. So the conditions are logical expressions, and you know that logical expressions return true or false. And this way you can add many else if statements. Condition 3, again chorus, and finally you have else. So if none of the previous conditions match or returns true, then it will come to the else and it will execute the code inside the else block. Before we go deep in if statements, I would like to tell you about blocks and scopes. Blocks and scopes. What are blocks? Blocks are some piece of code inside curly braces. So here you have one block, here you have another block, and here you have another block, and the whole function, this one, is also for itself another block. So you specify a block by using curly braces. And what is a scope? A scope is the area where your variables have meaning. This block is the child scope of this block, the block of function. Let me show you an example of scope. Let me show you an example of a scope. Here I create a variable, integer x, let us say 10. If x is greater than 11, then here we also create another variable, int y 20. If x is greater than 5, copy, paste, another variable z, x is greater than 5. It reaches here if none of the previous conditions are true. So x has meaning in its scope. So this scope is its scope. And this scope that is below its scope is its child scope. And you still have access to x. And here we have this y variable, integer y. If I want to access the y here, I will get error. Now you see here, identifier y is undefined. So it has no meaning in another scopes. So this is very important. Now we are using a modern advanced code editor. If this was Notepad, we did not receive this error immediately, but during the compilation, undefined means it has no meaning here. The only difference between variable and string for the compiler is that the strings have double quotes. Any character that does not have double quote or single quote, for the compiler it is a variable. Even if I say here, for example, this is for the compiler a variable, and if you see, it says identifier, this one is undefined. But if I wrap this in quotes, then it is a string, there is no problem. So that's the only difference for the compiler, what is a string and what is variable. Y has no double quote, no single quote, so the compiler sees it as a variable and it says it is not defined. But in its scope, it has meaning and it is defined. So I have to remove this, and I have to also remove this one. Now you see here x is greater than 5. This is from here, and then you have x is 10. That is from here, and the result is this one. By default, cout does not print a new line. So if you want a new line, you have to add new line like this. And in the same way here, you see something interesting here. X is 10, x is not greater than 11, x is greater than 5, x is equal to 10. We know this one is true because the previous expression matches the condition. It executes the code inside this block and then it stops and it does not go further. That's also something very interesting about conditionals. So I added here new lines. Let's see the new result. Now here you have new lines. X is greater than 5, x is 10. The result is. In conclusion, a block is a scope. So R has meaning in this block, but not out of this block. I hope it was clear about blocks and scopes. Now that you know the if-else statement and you also know the operators, let us create a basic calculator. String user input. We should use get line, ca, and user input. We have to include the string. So here we ask the user to enter math operations like 2 plus 3, and then based on the user input we do stuff. First we have to make sure that the user input is not empty. So user input dot size, if the length of the user input is greater than 2, then we have to check the operator. In this project we are doing only 4 operations: integer, and then we search for add operator. We call it add op, and then we search in user input dot find, then we pass here the character. The dot find method returns the index of that character. Operator full name is much better. Also pay attention to the naming convention. So this is called camel case. In camel case, if you have multiple words in your identifier, the first word is all lowercase and the other words are also lowercase except the first letter. So the first letter of all other words is uppercase. So we copy this 4 times. For subtraction operator, for multiplication, for division. So if it include minus operator, this operator, let's use this operator, and then this operator. So if it has a positive number, it means that there is the operator. Then we have to find the left part and the right part of the operator. String left part. Then we can use the substring method. The substring. The substring takes one or two arguments. The first one is the start index, and the second one is the length. How many characters you want to get from your string. So for the left part, we start from 0, and then how many characters we want? We want from 0 to this index. So add operator plus 1. Because the string starts from 0, we have to do plus 1. Add operator plus 1. It is for the left part, and then copy and paste this for the right part. So the right part starts from the index operator to the end of the string. So user input dot length -1. As probably you have noticed, this one is not correct. This will throw error. Why? Because we take only from the operator part. For example, here we have 2 plus 3, and 2 is index 0. Then we have here white space index 1, the operator index 2. So from index 2, we only want to take the index 3 and index 4. So here we say the whole length. We'll take the whole length, and this will throw error. This one should be plus 1, because we want to get only the number part, not including the operator. And this one we can use the linked minus left part dot linked. Let us use the size, and also -1, because we don't want to include the operator. Before going further, we have to test this. So we have to print here the left part and right part. New line, the left part is, copy this one, the right part is, you also have to print the operator. Control C, Control V. The add operator is, so enter math operations like this one. Let's say I want 3 plus 5. So the add operator is 1. So here is 3 is index 0, plus is index 1. The left part is 3 plus 1, and the right part is empty. So we have to correct it first, the left part, remove the plus add, and then the right part, let us remove the -1 and try again. Let us this time also add white spaces and also larger numbers. 1 5 3 4, white space plus this number. The add operator is 5, and the left part is correct. The right part is also correct. The left part and right part and the operator is okay. Now the left part and right part, these are strings. We have to convert them to integer. Integer left. One way to convert from string to integer is to use the stoi function. It takes a string number as argument, for example left part, and then copy paste, call it write part, and then result integer result is left plus right. Now we print here the result is result. Let us try the add operation. First the basic 5 plus 3, we expected 8. So the result is 8. It is working for the addition operator. To do the subtraction, multiplication and division, we have to do this part over and over again, and it is not good to do that. For not repeating ourselves, I want to do this once using function. So here I create another function. It returns also integer, substring as number, integer, the start position, and integer. I also have to pass the string, call it main. From the main string, I want to just take the substring. So string substr, and then main dot substring from start and to total char, and then just return stio substring. Let us check it first here. Substring as number, here the user input, the start is here 0, and the end is the add operator. So this one returns immediately integer, this one should be integer, and we do need in this one now. Instead of just left, we use the left part. Now we don't have the left part as a string. We should use the add operator. Our function should not be here, so Control X, bring it before the main function. You can now do the same thing for the right part. Let us try it out. 2 3 plus 1 2 3, so 2 4 6. It is working perfect. We can improve our code. Let us create here 2 more variables. Let us improve our code further. Now you know how to create function. This time we create a function to return a string. Find operator. Let us create also another function, integer, index of operator. We pass here also the string main, and char operator, it returns main.find operator. You see here an error because we used here C++ reserved keyword. In case you use the C++ keyword and you get error, to avoid that, you can use underscore and your error will go away. Let us change the index of operator. Instead of that, let us use this one. We don't need this one. So here we say if add operator return add operator. So if subtraction operator, we return subtraction operator. So if multiplication operator, we return multiplication operator. Otherwise we return division operator. Int index of operator, here we get index of operator, user input, and then we directly put this here. Change in this to index of OPE, and then here we use user input dot find character plus, we just do the result for the plus, and then we don't need to repeat this one, just use this. And this one is not necessary. Let us try them out. This number plus this number, the result is 1. Let us check why by printing stuff from here. Control C, and then here also Control V. Subtraction, multiplication, division, add, subtract, multiplication, and division. Let us also print the find. So the find returned this. Let us see what is the index of operator. As you see, our code contains bugs, and fixing bugs is part of programming. Even if the user input does not contain any of these characters, it still executes the code inside these blocks. So we have to fix that. So this has to be the same as the index of the operator. Otherwise it is not that operator, and we don't want the code inside that block to be executed. Let us try again. One plus 3, 4, and you see only add here. 2 minus 3, we expected minus 1. So now we see here 1, and also add multiplication and division. So for the plus it works, for the minus it does not work, for the multiplication it does not work. And let us see for the division. Five divided by 2. So again we see add, subtraction and multiplication. We don't see the division. Here as well we have to add more stuff here. It has to be less than the size of the main string. So less than the size. And also it should not be minus 1. So if it cannot find, it will return minus 1. And add operator not equal to minus 1. And we add this to all of these expressions. Change this to sum. Change this to multiplication. Control C, and then change that to division. Control X, Control V, Control V, Control V. Return the index of the operator or return minus 1. Let us try again. 2 plus 3, 6 minus 3, 3 subtraction, perfect. And then 3 times 2, multiplication, very nice. Then for division, 6 divided by 3, we expected 2, so division 2. Now our basic calculator works perfectly. We struggled a lot, but we did it. Switch statement. You have the switch keyword. So here you have the value, and then based on the case, you check if the value is the same as what you give. For example, character 1, you entered 1, and then you have to use break to break out of that switch, otherwise it will do all the cases, which is not necessary. Case 2, you entered 2, 3, we pass here the user input, we change this to char, so this one is also not necessary. Then you have the default, you enter something else. In default, it is not necessary to use break. Let us try it out. So I enter 1, said you enter 1, I enter 2, you enter 2, and then I enter here this, then you enter something else. Switch statement is not used so much, but at some scenarios, in some situation, it is very useful, and it is much more simple than if else statement. Loops in C++. In case you have to repeat some part of your program multiple times or more than once, then you can use loops to do that. There are different types of loops. You have while loop, you have do while loop, and you have for loop. Let me show you the syntax of while loop. You have the while keyword, and then here you can pass the condition. You can execute this block of code until this condition is true. For example, integer I 0, I say here while I is less than 5, I is I, and then we have to do the stop so that the loop stops. Otherwise you will end up with infinite loop, and that will overload your computer's memory. So I plus plus, in every iteration we increase the I until it is less than 5. It will get increased. After that the loop stops. The final value of I is I. You see here error, and it says identifier cout is undefined. Using namespace std. You can also use the std here, but you have to use it multiple times, but so we import it at the beginning of our program. You see there is no new line. Add here also new line, also here new line. Save it, compile it again, execute it again. So I0, I1, 2, 3, 4, and the final value is 5. Here I is 4, and then it increases the I by 1. The I becomes 5, and then I is 5. It is not less than 5, so the loop stops, and then it continues to the rest of the program that we see the final value of I is 5. It is important that you know that while loop is not used for such thing, to loop over list, to loop with a number, to loop with a counter and stuff. While loop is used for processing. For example, you say while your file is processing, while a specific task is processing, do this. After it is done, you set it to false and then the loop stops. Let me show you an example. Here I ask the user to enter something. So I change this to chart to character. While it is not 7, we keep asking the user to enter something else. CNI, so we don't have to increase that anymore. So until the user has not entered 7, it will just ask to enter something. Let us bring this. Please enter one character. Please enter one character. I enter one time 1. So now 1 is not equal to 7. Until it is not 7, it keeps asking the user to enter. Say 2, 3, 4, 5, 6. If I enter 7, it still asks us, because 7 number is not equals to the 7 character. So I have to change this to 7 character. To terminate your program, you can use Ctrl+C multiple times and it will stop the program. That way you can get out of the program whenever you want. So recompile and then execute 157. The final value is 7. So while loop is used for such scenarios. Then you have do while loop. The only differences between do while loop and while loop that you execute first a block of code and then you check the condition. So you have first do and then while. You just bring it here. The program executes the code inside this block even if the condition is not true. So first time please enter one character. We say 1 and then you don't see the first time because now I is not 0. 2, 3, 7. I hope you understand now the difference between do while and while loop. Now let's talk about the for loop. You have for keyword and then you have your loop variable, your loop counter variable. Let's say I. Again we have the I there, so let's say j. It is kinda the convention that you use I, j, k and these letters for your counter variable. And then you have here the logic. While j is, for example, less than 11, then you also increase the j and here you write your code. To comment multiple lines at once, you can use control plus slash. Control plus slash to comment, control plus slash to uncomment. So it toggles the comment. So here we say start from 1. I want to say hello here. Hello world. And then j. You can also loop through each character of a text string hello world, and then we say j starts from 0 because the index of any variable, anything, starts from 0 in programming. So here we say hello world dot length, because the length is one number higher than the last index, you have to do -1. And then here, instead of saying hello world, we can say kv and then j the index. You know how to get a character from a string. So here you also see the j, which is not necessary. So remove the -1, because if you do also the -1, you have to add here less than or equal to. Now it is okay. Hello world. You can also nest loops. Let us create here an array. We will talk about arrays after this chapter. Just for now, the type of your array, and then the identifier of your array, square brackets, the size of your array, the size of the first dimension, and the size of the second dimension. We create here a two-dimensional array, and then we give value for each dimension. So the first dimension, let us say 4, 8, 9. Then for the second dimension 3, 7, 5, and we loop through that. We know the length of the first dimension 2, again 4 int k 0 k less than the length of the second dimension 3, and k plus plus to increase that. Then here we print the value of each dimension to the console. Just a white space for more readability. And then the name of your array, square bracket, index of the first dimension, index of the second dimension, and then print a new line after each dimension or after each row. This is how you can print a matrix in the console. Or to visualize a two-dimensional array or a two-dimensional matrix in the console in the form of two-dimensional data, for example. So you see it in this way, like a two-dimensional, like a matrix that probably you have seen at school. This is a matrix with 2 rows and 3 columns. Arrays in C++. You can create an array in C++ with specifying its size or without specifying its size. It is say integer my numbers is 1, 2, 3. By adding square brackets at the end of your identifier, you can tell the compiler that it is an array. And here you can specify the number of elements in your array, or you can just leave it like that. But once you specify the length, you cannot add another value to your array. To access or modify the items of your array, you can use its index number. And index number starts from 0, you know that. For example, my numbers, I want to change the second item to, let us say, 10. Let us see what we get when we just print the whole array in the console. So this is the memory address of this variable. To see the content of an array, you have to loop through your array. So create here for each loop. You have also for each loop and for loop. You can say here integer item in my number. Then here you can print the item. So you see here 1, 10, 3. Here is 1, 2, 3, but we change 2 to 10. That's why we see here 1, 10, 3. So this is the syntax of for each loop. In for each loop, you don't need a counter variable. You don't need to increase that and pass here logic. You just loop through the content. In case you get a list from an API and you want to know the size of your list, you can use the size method. Let us create here an array of string cities Delhi, Kabul, New York. For int I 0 I less than size of, and then you pass here your array. All these values take space in the memory. So size of returns the total size of all the values in your array. So that's why you have to divide that by size of your type. And then I plus plus. The city name is cities I. Also have to print a new line. Let us see. So you see here the city name is Delhi, Kabul, New York. So this is how you get the size of your array or the number of items in your array. Let us talk about break and continue. You saw break in switch statement that you used to break out of the statement. Paris, you have the city Ghent. If and you will see the difference. We see Delhi, we see New York, and we don't see Paris and Ghent. Why? In Kabul, it just jumped one iteration. So when it was Kabul, it jumped this iteration. It printed the New York. When it was Paris, it just break the loop. When you break the loop, you just stop the loop. But continue just jumps one iteration. So that is just the whole difference between break and continue. Let us modify the value of Paris to something else. So cities, Delhi is 0, Kabul is 1, New York is 2, Paris is 3. So the index number is 3. Pass x, y, z. X, y, z. Let us see. So now instead of Paris you see XYZ. Structures in C++. Arrays are used to store multiple values of the same type. If you want to store multiple values of different types in one variable, then you can use structure. You can also use structures to create your own custom type. Structures are also called struct. Let us create a structure. You use the keyword struct. You have the keyword struct and then the name of your structure. For example, car, and then curly braces. And inside of this structure, you can create multiple variables of different types. For example, string name, the name of your car. Then use semicolon to separate the members. So every item in the structure is called also the member of the structure. Float price, float discount, integer, build year. This is enough for an example. Now how to use this structure? We create a variable of this type. So for example, BMW. And then for this we gave multiple names. So BMW dot name, you gave BMW, and then BMW, for example, it is given a very cheap price, 0.1 or 10%, for example. For example, this is an old car. Let us create another instance of this structure. %20 discount. It is from 2019. The same way you set values for the variables of your structure, you can also get the values of the content of your variable or the member of your structure. For example, let us print the build year of BMW. The build year is BMW dot build year G++ structure. So here the build year is 1992. Here we created a new instance of this structure this way by using the name of the structure like a type, but you can give the name directly during the creation of the structure or when you initialize your structure. BMW and then use comma, and then like that. If you remove this, it will still work. Recompile, clean the console, execute, and this is the same. I think this is faster. So it is also not mandatory that you give a name here like this. You can create a structure just without name, and then use this instances or copies of this structure. When you create instances immediately during the initialization of your structure, later you cannot use this actually. So in case you want to use it later, you can give it a name and then use the name to create a new instance or like a data type. When you give your structure a name, it is called named structure. For example, like this. Now this is a named structure. So this was all about structures in C++. Structures are not that complicated. I hope it was clear. References in C++. What are references? References are used to reference one variable to another variable, or to reference to the value of another variable. For example, how to reference this variable name? You can use AND character to reference another variable. Copy name, and then we gave the value of name. Now these both variables have the same value. The AND operator that we use to reference to another variable or to create a reference variable is also used to get the memory address of a variable. The memory address is the location where the variable is stored on the computer's memory. Let me show you how you can access the memory address of a variable. The memory address is, use this operator and then the name of your variable name. The memory address is always hexadecimal number or hexadecimal value. When you see 0x and then this like values, it means it is hexadecimal value. So this is the memory address of the variable called name. Probably you wonder, why is it useful to know the memory address? Well, references and pointers are important in C++ because they give you the ability to manipulate the data in the computer's memory, which can reduce the code and improve the performance. References and pointers are one of the things that make C++ stand out from other programming languages like Python and Java. Pointers in C++. What are pointers? A pointer is a variable that stores the memory address as its value. A pointer variable points to a data type of the same type and is created with a store operator. The address of the variable you're working with is assigned to the pointer. To create a pointer variable, you can do it like this. The data type and a store and the name of your variable. For example, name. You can put the store close to the data type. You can put it between white spaces, or you can put it close to the variable name. But putting the store close to the data type is preferred, and it is kinda the convention. So this one is preferred. Let us create here a variable string city, let's say New York, then reference here, get the memory address of the city. There are two interesting terms. This operator is called reference operator, and this store is called dereference operator. So it is interesting to know that. Now the name stores the memory address of the variable city. You can use the pointer to store the memory address of a variable. You can also use the pointer to get the value of a variable. Let me show you. The memory address is just the name, the value, then we can use a dereference operator, store, and the name. Now we have the value. This way you store the memory address, and in this way you get the value. You can change the value of your pointer, but you have to know that it will change the original value. Let me show you. In this way you can change the value of your pointer, store the name of your pointer, and then here assign a new value, for example Delhi. So you see the memory address is the same, but the value is different. Functions in C++. You probably know functions in practice, but there are some theories about functions. There are some terms about functions that you should know. What are functions? Functions are used to bring common codes and reuse them, or to reuse common codes of your program. Instead of repeating them, you can bring them under one variable or one function and reuse them. The beauty of functions is that they accept arguments, that you can pass values to your function and get different result and different output for different values. Let us create here a function for introduction. It returns a string. I call it self intro. We pass here the name of the person, the age, and the language, and we return a template string. Hello there, new line, plus my name is. We concatenate that with the name. Again, new line, plus I am. Here we can use the function toString to convert the age and number to a string. Years old. As you see, here is an error, and it says expression must have integral or unscoped enum type. In another programming languages, when you jump to the next line in a string, you have to use the plus operator, the plus sign. If I compile this program, you will see the actual error. Here, when you hover over the error, this message means like nothing. It is a very general message. If you search this error message, you get another result. So it is much better that you compile and then you get a better error message. This is a better error message. Invalid operands of type const char2 binary. And it says operator plus, which means that here this operator, we do need this. It also shows which character is wrong here. So if you remove this, the error will go away. Now it is fine. You have two important terms in function. You have parameter and argument. The variable that you use inside your function is called parameter. For example, in this case, this function has three parameters: name, age, and language. But when you call this function, you have to pass three arguments. When you pass the value, you pass arguments, but it takes parameters. So I pass here three arguments because this function takes three parameters. Hello there, my name is Khalil. I am 39 years old. I can speak Dari. Now let us create a currency converter. We create here a function that returns float number, float currency converter. Here we get a float number as the amount, and then another float number as rate. We return the amount times rate. Amount, for example, float rate, for example 0.86. For example, the amount is in this case dollar, and you want to convert this to euro, and we say here amount dollar is then we call the currency converter amount and rate. This match in euro. We can also ask the user to enter the amount and also the rate. Let us check it out. So please enter the amount. For example, so it says $980 is in this much in euro, but we have to change in this to Indian rupee. So this much dollar is this much in Indian rupee. You will be rich. Interesting information about C++. So C++ is a cross-platform language that can be used to create high-performance applications. C++ is built on top of C language. C++ is one of the world's most popular programming languages. It can be found in today's operating system, graphical user interfaces, and embedded systems. They call it a portable language because it can be used to develop applications that can be adopted to multiple platforms. Learning C++ helps you to learn C# and Java faster and easier. Object-oriented programming in C++. We have procedural programming or function-based programming and object-oriented programming. Procedural programming is about writing procedures or methods that perform operations on the data, as you have seen so far in this course. We created a function called self-intro. We passed some data, it processed the data, and it returned the result. Object-oriented programming is about creating objects that contain both data and methods. What are the advantages of object-oriented programming over procedural programming? Well, object-oriented programming is faster and easier to execute. Object-oriented programming provides a clear structure for the programs. Object-oriented programming helps us to keep the Java code dry. Dry is an abbreviation for "don't repeat yourself". It makes the code easier to maintain, modify, debug, and extend. Object-oriented programming makes it possible to create full reusable applications with less code and shorter development time. One thing about the "don't repeat yourself" thing, it is a principle about reducing the repetition of code. So you should extract out the codes that are common for the application and place them at a simple place and reuse them instead of repeating them. So in object-oriented programming, we have classes and objects. What are classes and objects? Well, classes and objects are the two main aspects of object-oriented programming. Classes are templates. Templates for creating different objects. Many objects of that template. For example, you can have a template for car and then reuse that template for different cars with different models, with different prices, different colors, and etc. You can create a class, a template, a container for products of your company. For example, if you're selling different tools, for example, you have pot for cooking, then you can create a class of pot with different size, with different functionalities, different prices, and etc. Classes are inheritable. You can inherit from one class to extend your class. So classes are extendable, maintainable, reusable. Access specifiers in C++. There are three access specifiers in C++: public, protected, and private. They are used to protect the members of the class. You can apply abstraction, encapsulation, and etc. on your class. So you have all these functionalities in object-oriented programming. Let us jump to the code and see examples of classes and objects. Let us do some examples of object-oriented programming. I have prepared some stuff to save times. This is the class car. This class has these public fields or attributes or properties, and one private attribute is sold, and then one protected attribute, internal nodes, then a public method. A function inside a class is called method. That is just a term. Then here is another class, the class person. Here we have public keys, name. This has to be age, country, and language. Then here we have inheritance, that the class student inheritance from person. Inheritance is used for the purpose of reusing your code. Now the class student has also these four properties or attributes. We extend the class person and then we add the class name study field and is graduated, and also here we create a constructor. So this is how you create constructor, and you also can pass values to your constructor. Constructor is useful when you want to pass values to your object during the creation of your object. Let us use the class core. Inside the main, we create a copy of the core class, and it's also called instantiating a class, or create an instance of that class which creates an object. And then we can add real world values to that object. My car. So this one is an object now. Then we can use my car and then use dot operator to add values. Model is a string, so we add text. Let us say Citroen 2019. My car dot price 3500. Here we see an error because the model must be a string. Let us give it 25% discount. 2019, and then we have a method there to return the price including the discount, and we can store that in a variable. Let's call it int price. The int price is int price. About the naming conventions in class, so the name of your class must be Pascal case. In Pascal case, the first letter of each word is uppercase. And then for the naming of your attribute, you use camel case, which means that the first letter of each word is uppercase except the first word. Like this is sold. Internal notes. G++. So the in price is this much. Okay, we made a mistake in the calculation of the discount. It has to be times 1 minus discount. Recompile. Now this is okay. So the new price is with discount 2625. So this is for example for Citroen. We can create another copy of it. Let us copy the whole thing and call it my car 2 and change everything to 2. So this is the beauty of class, that you can create one template and then reuse it for different values. For example, you work for a company that sells different products, and then you create for each product one template and then reuse that for the same products of different price, different names, and different size, and etc. And then my car 2, we call this one, for example, Opel. We call it 1998. The price, let us say 2900. We gave it no discount, so pass here just 0, and then the year 1998. In price 2, the in price for the second car is, so the in price for the second car is the same price because we gave no discount. This was an example of a class with no constructor. Let us do an example of a student, because here we have also constructor and we also inherit from the class person. A student, the best student, and now you see here error because it says no default constructor exists for class student. So you kinda have to pass here some values. So what we have to pass: name, age, country, and language. For the name we pass, for example, Khan, and then the age 23. For the country pass India. For the language we pass. So let us print the student name and check if it is okay or not. The best student dot name. We got nothing. So why? Here we pass value for the name and then we want to print the name, but it shows nothing. The reason is because the name of this parameter, this variable inside the constructor, is the same as the name of the attribute, here string name. If we change this, for example, from name to something different, name1, recompile and execute, we get the correct result. So in C++, the name of parameters should not be the same as the name of your attributes. Let us add underscore instead of number. It is much better. Also for the country, so language is different, so it's okay. This way we can print all of it. Let us create here a template. Control C, student dot name plus white space and then plus a student dot age. So this one is a number. You cannot concatenate a number with string, and this white space is also one single character, so it should be like that. Pass here integer value. So Khan 2 times actually, and then the age, the country, and the language. So I forgot to remove this. So name, age, country, and language. So this was all about classes, objects, and object-oriented programming. Object-oriented programming is not that complicated. In conclusion, you have access specifiers. Sometimes it is also called access modifiers. You have public, private, protected. Public is, it means that the attribute, method, and fields are publicly available from anywhere. Private is not accessible from outside the class. Protected is only accessible in inheritance, not outside the object. You cannot access it from the object using dot operator. And then you have method. It is just a function that you also can pass here parameters and then give arguments. And then you can inherit from another class using colon. In case you want to pass initial values to your object, you can create constructor for your class, and then when you instantiate or create an object of your class, you can pass default values. I hope it was clear. Let us create a project to manage the products of a company. Create here a file, product manager.cpp. Import the basic stuff, include IO stream, include string using namespace std, and then here we should create a class for the product type, class product public, and then here we gave price and name. In the real world, you add stuff in a database. Now I don't want to make the course complicated by also talking about databases and then querying, sending, receiving, updating, deleting products in the database. We are going to use just array and then store and manipulate and modify the array to store and do stuff with the product. In C++, you cannot modify an array at runtime. That is why you need another library. Include Victor. This way you can create an array with a specified type that you can modify during the runtime programmatically. So use product, call it products, and then we can use productors.pushback, and we can add here a product of type product. It is much better that we add also here a constructor to add this stuff when we create a product instead of using dot operator. Product, and then we pass here string name, price, and then name to name, price to price. Just for example, I add one product to this list. Product, for example, apple, and then here I pass default value, apple, $2.3 for each kilo, for example, and then products dot pushback. Then let us loop over this and then see the content. For product item in products, name item dot name, let us use tab, and then price item dot price. Let us copy and paste this and make it 2 items. So name apple, price this, name orange, price this. We also have to print a new line here. Now this one is much better than this one. Let's also calculate the total price. Total, and then give it an initial value 0 and say total plus item dot price, and here print also. Let's also give it a header, name, and use some tabs, and then one tab, total, and then here instead of doing this, here we have 4 tabs and here I give 5 tabs. 1, 2, 3, 4, 5. For space between the name and price, 1 tab is enough. So 1 tab between name and price, and when we give 2 tab for space between price and total. Let us check it out. So let us see, we forgot to put a new line here, that's why you see it here. Here we have to add a new line, and also here a new line, so that we see the next one on the next line here. So name, price, total, so we have to manage in this as well. So now it looks much better. We also need to add a new line for the title so that it comes down. This one is not necessary. Now it looks better. So the total is kinda below this, and then you have this one, this one. Here we also should give a new line so that the title comes a little bit down, and then at the result we give here also a new line. See, now it is better, but this new line did not work. Okay, now it looks much better. So we added here 2 products. Now let us remove this and then ask the user to enter the items, the product's details, like the name and the price. Is done. False. While we ask the user to enter the details. String name, float price. It is possible that a product has a very large name, so we should use getLine, and then cn and the name of the product. It is called price str string because we get it as a string. Price string. We ask the user here to enter the name. And then use stof to convert from string to float. product, and we pass here the name and the price, and then we add the product to the products. It is pushback. Then here we have to ask the user if it is finished or not. String done, cout, are you done? We say yes or no. Done. So here we check if it is yes or no. If done dot find yeah greater than less than or equal to done dot size and done dot find yes not equal to -1. So when we set this to true, this loop will stop. We will continue to the rest of the program and then we will see this stuff. Let us play it. So enter the name. We say for first time PC, the price this much, and then are you done? I enter no. Okay, we have to debug. There is something wrong with this program. And also this. Let us try again. Please enter the name of the product. Please enter the price. All of them at the same time. You have to change this to equals to 0 because the index of that will be 0. In fact, this is also not necessary. So only if it is 0, we set the is done to true to stop the loop. So that one is not necessary anymore. To solve this problem, we should create a function to return the user input, and that is much better. We're also repeating ourselves here. So let us create a function above here. Terminate this, exit. This function returns a string. We call it user input. We pass also the hint so that we can use this string input, and then we print the hint get line cn input, and then we return the input. Here we also can add validation. If the user input is not empty, we can return. Otherwise we can also ask that the user input is empty, and you cannot enter empty. So for now it is not necessary. We will not submit empty string. So let us use that here, user input, and the hint is this. Then let us also do that here, user input, and the hint for the price is this. This one is not necessary anymore. And the same way for the done, user input, and the hint for this is this one, also not necessary anymore. I comment this out for now just to check. Let us say Apple 1.3 done. No, now you see it is working very good. Please enter the product name. Orange 2.5, no. Enter the product name, PC 1200, done, no. And then cell phone, it is say in this price, done, I say yes. Now we see here an overview of our product and the total price. Now our application is working perfect. Let us remove this stuff, it is not necessary anymore.